Now this question is worded first asking you to express the function as a trinomial. Right now it's not just three terms, we have those two parentheses in the front, and then to solve for x when m of x is equal to 0. So the first thing I'm going to do is simplify the product of the binomials again by the box. We want 2x minus 1 times 2 minus x. We have 4x minus x, and 2x is negative 2x squared, negative 2, and positive x. So I'll put the negative 2x squared in the front. Here the like terms are over here. 4x and 1x is 5x, and minus 2. So I have m of x equals negative 2x squared plus 5x minus 2. Bring down the 3x squared and the 8. And then we have like terms on the same side. So the 2x squared terms, the negative 2x squared and the positive 3x squared, since they're on the same side, I just combine them, and I get 1x squared. There's just one x term, and then two constants. Again, the negative 2 and the positive 8 are on the same side of the equation, so I just combine them. Okay? Except negative 2 and 8 is 6. Sorry. Okay? That is now a trinomial. We have x squared, 5x, and 6, three terms. Luckily, the leading coefficient is 1, so we do not have to split the middle here to find when the value of x when m of x equals 0. So since they want to know when m of x equals 0, I'm going to replace the m of x with 0, making this a standard form quadratic equation that we're now solving for. Add, multiply, again because the leading coefficient is 1. Everything is positive. So when I finish with the x's in the front, what two numbers multiply to 6 and add to 5? This combo comes up a lot, the 5-6 combo. It's positive 3, positive 2. Then tee it up, set each equation equal to 0, each factor equal to 0. I'll get negative 3 and negative 2. And those are my solutions. So you first had to have this, no, not that one. You first had to have this line here defining the function as a trinomial before solving. Okay, here number 5, they're giving us f of x and g of x. They want us to determine the values of x that satisfy the equation f of x equals g of x. So they want to know when these two functions are equivalent. Now graphically we could do that. Okay, graphically, if it didn't say to show your work algebraically, I could put x squared for my first function, x is my second function, and do you see when they're equivalent? We have an intersection there when x is 0, and an intersection there when x is 1. So when x is 0 and x is 1, those two functions are equivalent. So graphically, that's how you would support that answer. How about algebraically? Algebraically, if we want to know when f of x is equal to g of x, I am going to set x squared equal to x. When you have that x squared, we know it's a quadratic equation. We need to get it set equal to 0. I'm going to subtract x from both sides. X squared minus x is equal to 0. Now this becomes, even though it's a very basic quadratic equation, a difficult one to factor. What is the first thing you look for would be a GCF. And what could you divide both of these terms by? X. So there should be an x in front of the parentheses for your GCF. X squared divided by x is x. Negative x divided by x, the x's cancel, you have a minus 1 here. So using GCF, I have the two factors x and x minus 1. Set each of them equal to 0. And I get 0 and 1, which were the same two x values we just found graphically, were when the two functions were equivalent. And lastly, a multiple choice question. These are the zeros, x equals 3 and x equals 9. Sorry, x equals negative 3 and x equals positive 9. That means negative 3 and positive 9, or sorry, just negative 3 is not going to be one of the factors. And if a solution's positive 9, that eliminates choice 1 because positive 9 is not going to be one of the factors, leaving us with just one choice. More importantly, though, let's look at if x equals negative 3, the factor before that would have to be x plus 3 to give you a solution of negative 3. If the other solution is x equals positive 9, then that gives you that the factor must have been x minus 9 to get that solution. So the zeros, or the solutions, are always going to be the opposite of the numbers and the factors. So if you have a negative 3 as a solution, you're going to have a factor that has a positive 3. If you have a positive 9 as a solution, you need a factor that has a negative 9. It has opposite relationship, the zeros or the solutions with the numbers and the factors.